Now we are going to study about the differential and point of elasticity. So we have a demand function Q equals to Fp. Okay. So we know that the elasticity of quantity demand is as a response to the change in price. So as we know that elasticity of quantity demanded as a response to change in price, we can write the equation as change in quantity upon original quantity upon change in price upon original price. Okay. Now replacing delta Q by dq and delta P by dP. So we will get the elasticity of demand equals to delta Q upon Q divided by delta P upon P. Okay, we can also write it as dq upon dP by Q upon P. So here's the elasticity of demand. So for example, we have a new function y equals to fx. So we can write the elasticity with respect to E xy equals to, just write it as change in quantity of y upon original y upon change in quantity of x upon original x. Now replacing delta y by dy and replacing delta x by dx, we get dy upon y by dx upon x. So here we get this. Now we can also write it as dy upon dx by y upon x. Now dy by dx is also known as the marginal function. Marginal function. And y upon x is known as average function. Now since this is marginal function and this is the average function, we can now change it to the ratio of marginal function upon average function. Okay, now we'll study about some measures of elasticity. If elasticity of demand is more than 1, it is elastic. If elasticity of demand is equals to 1, it is unit elastic. If elasticity of demand is less than 1, it is inelastic. Okay, now we will take an example. Suppose the demand function is given as Q equals to 100 minus 2p. This is the demand function. Okay, now according to the now we have to find the elasticity of demand. Okay, so here first we know that we have to find the elasticity of demand, we will have to find dq upon dp, which means that we have to derivate it with respect to p. So to find dq upon dp, we will derivate it and we will get minus 2. Now we have to find q upon p. So Q is given as 100 Q upon P. So Q is given as 100 minus 2P. Now we don't know the value of P, so we will put it as it is. Now according to the equation, we have to divide this dq upon dp divided by q upon p. So find the elasticity, we divide this. Here we get minus 2 upon 100 minus 2p by p. So further solving, we get minus 2p upon 100 minus 2p, and eliminating 2 will get minus p upon 50 minus p. So this is the elasticity that we have found.